This is the video lesson for number 8-5. Today we're talking about translations. We have some definitions that we need to remember from 8th grade. The first one is the image. This is the new figure after a transformation. The pre-image is the original figure. So we start with the pre-image, we perform some kind of transformation, and then we come up with the image. Transformation, this is a general term that explains how the pre-image becomes the image. Translation, a translation that slides a figure from one position to another without changing its shape, size, or orientation. Pre-image and image are congruent. The line segments between the image and pre-image are parallel and have the same length. Our next one is isometry, a transformation that preserves length. These are the three isometric transformations: translation, rotation, and reflection. So if it preserves length, when I do a translation, all the lengths are still the same. When I do a rotation, all my lengths are still the same. And when I do a reflection, all my lengths are still the same. The important thing with the translation, it slides a figure from one position to the other. It does not change the shape of that figure. It does not change the size or the orientation, so it's still facing the same direction. And that's when we say the pre-image and the image are congruent, which means they have the same size and the same shape. The other thing that's important to know is that the line segments between the image and pre-image are parallel and have the same length. So we're going to be doing that today to show how when we perform a translation that the line segments between the image and the pre-image, so between the original and the new one, are parallel and have the same length. Okay, let's go ahead now and turn to page 368. Okay, so number 1, given triangle ABC with vertices A, B, and C, graph the image of triangle ABC that has been translated by this translation notation right here. So let's go ahead and plot these points A, B, and C. So A is 3, -1. B is 0, -4. And C is 4, -5. Okay, and we're going to go ahead and connect those points. Okay, now we want to perform the given translation of the vertices of triangle ABC. So let's go ahead and explain what's happening here. So this is telling me that whatever x is, I'm going to subtract 4 from it. And whatever y is, I'm going to add 7 to it. So if I have point A, which is 3, -1, I am going to subtract 4 from my x value and add 7 to my y value, and that's going to give me A prime, which is -1, 6. And I can plot that over here. So -1, 6, so -1 up 6. And this is my A prime. And I can see that A has gone left 4 and up 7. Okay, then we have B, which is 0, -4. Once again, we're going to subtract 4 and add 7. That's going to give me B prime, which is going to be -4, 3. So once again, we went left 4 and up 7. Then our last one is C, which is 4, -5. Once again, we're going to subtract 4 and add 7. So C prime is 0, 2. Once again, you can see we went left 4, up 7. Okay, we're going to go ahead now and connect points on the image. So just to remind you, triangle ABC is my pre-image. It's what I began with. It's my original figure. Triangle A prime, B prime, C prime is my new image. Okay, this is my, it's just my image. Okay, this is the pre-image, this is the image. The new figure, the original figure. Okay, the other thing that we need to remember that it said, I just performed a translation here, is that if I connect the line segments between the image and the pre-image, they will be parallel and have the same length. So let's see if that's true. So if I connect B and B prime, and I connect C and C prime, and A prime. Okay, so are they parallel? Well, to figure that out, let's go ahead and find the slope of each one. So the slope from A to A prime, we go up 1, 2, 3, 4, 5, 6, 7, and left 1, 2, 3, 4. So we have up 7, left 4, so that's just negative 7/4. So the slope of A prime, is negative 7/4. Okay, let's try B prime. So we're going to go up 7, 1, 2, 3, 4, 5, 6, 7, and left 4. 1, 2, 3, 4. Same thing, 7 over negative 4, which we know is negative 7/4. And then C, we're going to go up 7, 1, 2, 3, 4, 5, 6, 7, and left 4. 1, 2, 3, 4. So negative 7/4. Since they all have the same slope, that means they're parallel. Well, now we want to find the distance between A prime, B prime, and C prime. And we're going to do that using the distance formula. So we're going to review that. Remember, our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So our first one is going to be between A and A prime. So we're going to find the distance between A and A prime. A is 3 comma negative 1. A prime is negative 1, 6. And I just got that from up here because I knew what A was, and then once I did my translation, I know what A prime is. So I just brought it down. And now we're going to plug that in. So we have negative 1 minus 3 squared plus 6 minus a negative 1 squared, which is the square root of negative 1 minus 3 is negative 4. Negative 4 times negative 4 is a positive 16. Plus 6 minus a negative 1 is the same as 6 plus 1, which is 7. 7 times 7 is 49. And if I add that together, I get 65. So I get that the distance between A and A prime is the square root of 65 units. Okay, so now we're going to do that for B to B prime. So we have B to B prime, which is 0, negative 4, and negative 4, comma 3. We're going to go ahead and throw that in. So we have negative 4 minus 0 squared plus 3 minus a negative 4 squared. Turns out to be negative 4 minus 0, which is negative 4. Negative 4 times negative 4 is a positive 16. Plus 3 minus a negative 4 is 7, because it's 3 plus 4. 7 times 7 is 49, which is 65. So we know from B, the distance from B to B prime is the square root of 65 units. Okay, and our last one. Now we're going to go ahead and do between c and c prime. Which we know are 4, -5, and 0, 2. So we have 0 minus 4 squared plus 2 minus a -5 squared. We get 0 minus 4 is -4. -4 times -4 is a positive 16. 2 minus a -5 is 2 plus 5, which is 7. 7 times 7 is 49. And that again is 65. So we know between c and c prime, that is the square root of 65 units. Okay, so what do we know about the line segments connecting the vertices of the preimage to the image? Okay, well, first of all, there's two things that we have here. They all have the same distance. They're all the same distance. They're all the same length. So they have the same distance, or we can put length. Okay. And then the other thing that we've noticed is that they have the same slope. Which makes them parallel. Which goes back to our definition that said that the line segments between the image and the preimage are parallel and have the same length. Okay, now this next one here, we're given triangle ABC with these vertices and triangle A prime, B prime, C prime with the vertices. And we want to know what is the translation notation. What happened here? Okay, what's the rule? What occurred from A to A prime? What happened from B to B prime? What happened from C to C prime? Okay, so we're going to go ahead and circle all of our X values in pink. So I went from 8 to 11, 11 to 14, and 2 to 5. Okay, so translation notation needs a very specific way to write this. So let's go ahead and write the translation rule. We're going to put in the just kind of the format for it. So it's always X comma Y with an arrow. And then we're going to say what happened to X and what happened to Y. So this is always the format, okay, that you use every time you write the translation notation. Okay, so what happened to X? We went from 8 to 11, from 11 to 14, and 2 to 5. Every time we added 3 to X. So whatever X is, you add 3. Okay, now let's look at how we went from the Y's, from Y to Y prime. So we went from 2 to -3, from -3 to -8, and from -1 to -6. So how did I get from 2 to -3, -3, -8, and -1 to -6? Well, I took my Y's every time and I subtracted 5. So that's our answer right there. Okay, our last one is I'm given the image and I want to know what was the pre-image. What was my original? What did I start off with? Okay, and I'm given the image, the new one. I'm told what happened to the original, and so I want to go back and find the original now. Okay, so let's go ahead and talk about how to do this problem. Okay, so I know that I started with A prime, which is 9, -1, B prime, which is -4, 3, and C prime, which is 0, -6. And I know that To go from A to A prime, I subtracted 2. So to go from A to A prime, I subtracted 2. So how do I go backwards? If I subtracted 2 to go forwards, I need to add 2 to go backwards. So let's look at that one more time. If I subtracted 2 to go forwards, to go backwards, I'm going to add 2. So 9 plus 2 is 11. Negative 4 plus 2 is negative 2. And 0 plus 2 is 2. Okay, now let's look at our y. To go forwards, we added 4. So to go backwards, we're going to subtract 4. So negative 1 minus 4 is negative 5. 3 minus 4 is negative 1, and negative 6 minus 4 is negative 10. Okay, let's see if we did it right. So remember, we're going to subtract 2 to go from A to A prime. So 11 minus 2 is 9, negative 2 minus 2 is negative 4, and 2 minus 2 is 0. To go from our pre-image to our image, we added 4 to our y value. So negative 5 plus 4 is negative 1, negative 1 plus 4 is 3, and negative 10 plus 4 is negative 6. We did it correctly. Okay, so our answer would be those points right there.